Hello, welcome back. We'll start the second unit of applied physics, that is semiconductors and devices. In this video, we shall see the intrinsic and the extrinsic semiconductors. These are two different semiconductors with different properties. We are going to compare these two semiconductors basing on various parameters. The first parameter we use is doping. Doping means adding impurities to a material that is in its original pure form. In the case of intrinsic semiconductors, they are pure form of semiconductors. As such, there is no doping. While in the case of extrinsic semiconductors, the extrinsic semiconductors are made by adding certain impurities or dopants to the intrinsic semiconductors. So a small amount of impurity is dope. The second parameter we use is the density of electrons and holes. In case of the intrinsic semiconductors, the number of electrons in the conduction band will be equal to the number of holes in the valence band. Means the number of holes and the electrons in an intrinsic semiconductor are equal at all temperatures. In respect of the extrinsic semiconductors, the number of holes and electrons are not equal. The third property we discuss is the electrical conductivity. The intrinsic semiconductors have low electrical conductivity, while the extrinsic semiconductors have high electrical conductivity. The next parameter we discuss is dependency of electrical conductivity. In the case of intrinsic semiconductors, the electrical conductivity is a function of temperature. Electrical conductivity is a function of temperature only. Whereas the extrinsic semiconductors, electrical conductivity depends on both the temperature and the amount of impurity. Lastly, we shall see the examples. For intrinsic semiconductors, the crystalline form of silicon, germanium, they are the examples. And for the extrinsic semiconductors, arsenic, antimony, phosphorus, indium doped silicon, and germanium. In this video, we have started the second unit of applied physics, that is semiconductors and devices. We have discussed the differences between the intrinsic and extrinsic semiconductors. We have seen the differences basing on various parameters. The first parameter we have chosen is doping. The intrinsic semiconductors are the pure form of semiconductors, hence there is no doping. The extrinsic semiconductors are those pure semiconductors in which certain amount of impurities are added. The second parameter we have discussed is the density of electrons and holes. The number of electrons in the conduction band in an intrinsic semiconductor will be equal to the number of holes in the valence band. Whereas in the case of extrinsic semiconductors, the number of holes and electrons are not equal. The electrical conductivity of intrinsic semiconductors will be low, while the electrical conductivity of extrinsic semiconductors is high. The dependency of electrical conductivity in intrinsic semiconductors will be only on temperature, while in extrinsic semiconductors, the electrical conductivity depends on both temperature and the amount of the impurity and the impurity material also. Examples for the intrinsic semiconductors are crystalline form of silicon and germanium. Examples for the extrinsic semiconductors are crystalline form of germanium and silicon doped with arsenic, antimony, phosphorus, indium, etc. Thank you. Antimony,